All right, everybody, welcome to 9.5.39T, which is almost exactly the same as the last problem that I worked, which is 0.35, I think it is, 9.5.35. So I left up the calculator I made when I did 9.5.35. So anybody who watched right before this, watched the 9.5.35 video, I'll show you how to just use the same calculator to do this work. And then after that, for anybody who didn't watch the earlier video, I'll go ahead and make this calculator from scratch so that you can see it both ways. Anyway, but the first part of this question is just trying to get us to understand type 1 error. So a type 1 error can occur when a researcher concludes the average percent of households relying on cell phone blank, but the percentage blank. A type 2 error can occur when the researcher concludes the percentage of household relying on cell phone blank, when in fact, the percentage of households relying on cell phone. Okay, so we're going to say type 1 error is when we think it increased, but it did not increase. And type 2 error can occur when we think it did not increase, but in fact it did increase. So that's the first part. So for the second part, now we need to calculate the type 2 or the error or the beta. Okay, so again, this is the calculator I made for problem 9.5.35. And so I'm going to use that, and then again, like I said, afterward, I will go ahead and reconstruct this for people who weren't able to watch the 9.5.35 video. So our expected proportion is this one that we're testing for. So according to a survey, they're thinking it's 0.23. That's my expected. My N is my sample size. Here it's 140. Then it says using an alpha of 0.05, so I've got that alpha in place. Calculate the probability of a type 2 error occurring if the actual proportion of cell phone only households is 0.32. So my actual proportion is 0.32. And so this should all be good with one exception, and that is that before on problem 9.5.35, there was this rounding issue because they wanted us to use the table. But on this one, that shouldn't be the case. So I'm going to delete this, and then I'm going to change my beta here. Instead of looking at cell C8, it's going to look at cell B8, just my Z value without any rounding done on it. And that should be my beta 0.21216. It wants 4 decimal places. So 0.2122. Then it's going to say, using an alpha of 0.01, calculate the type 2 error. So all I have to do is go back to my calculator and change that to 0.01. And there's my new beta, 0.4269, which is 0.427. And then finally, it's going to say explain the difference. The difference is that as our alpha increases, our beta decreases, and vice versa. So it's an inverse relationship. So here it says decrease, decreased. That's not right. Decrease stays constant. That's not right. Increase, increase. That's not right. So it's got to be this one that shows an inverse relationship between these two. And there we go. So now what I'm going to do is I'm going to recreate this calculator for people who weren't able to do 9.5.35. So I'm just going to go back here and I'm going to do a similar question. So here's our similar question. I'm just going to delete all of this. And we'll go through the process of creating it. And hopefully that process will be helpful to you. Sorry about that. Okay, so we'll start back with this first part. Type 1 error can occur when a researcher includes the average number of households relying on cell phone increased, but the percentage did not increase. And a type 2 error occurs when we think it did not increase, but it actually does increase. So there's the first part. All right, so now to create our calculator. We'll start always with the information that we know. So our expected proportion is this one right here, what the survey people think it means, so 24%. Our N is the sample size of the survey, which is 128. our alpha, which is given to us right here, 0.05, and then our actual P, our actual proportion is 0.33. That's all the given information. So we'll have to calculate our critical Z. Remember, we can do that just by doing norm.s.inv and putting in the probability. And that finds our critical Z. And for the probability, we're using the alpha. But remember, I know this is confusing, but we always want this to be a positive number. So we're going to take the absolute value of that number. Because what happens is if we use the alpha of 0.05, then it's finding the point at which we have 5% chance, and that's all. And so it's that to the left, which will be a negative 1.64, but we want the positive, so I just do the absolute value of it. Then we have to find the critical P. The critical P is this critical proportion formula right here. And again, because we're testing, this is plus or minus, we're going to use the positive because we're testing that it is greater than, our proportion is greater than. So I'm going to say this equals my expected P plus my critical Z times the square root of the denominator, which is my expected P times 1 minus my expected P. And then my numerator, I'm sorry, that's my numerator, and then my denominator, which is N. And that'll give us our critical P. Next, we need our Z value for P. So I'm going to just say call it the Z value. And that's this formula right here. So that's going to be our numerator, which is our critical P, the P alpha, minus P. We're going to divide that by the square root of P times 1 minus P. There's the numerator over and the denominator. So there's our Z value, a negative 0.67. All right, so once we've found that, then we can find our beta, which is our type 2 error. And our beta is just the norm.s.dist for this z-score, comma true. All right, and so it wants us to round it to 4 decimals. Oh, it pre-filled my address for some reason. That was weird. Thanks, Google. And then now it wants us to calculate the same thing with an alpha of 0.1. So all I have to go back and do is change my alpha because my calculator is all set up. And there's my new beta, 1.1583. And then finally, explain the difference. Again, they want us to recognize an inverse relationship between alpha and beta. So we just look for where it shows an inverse. When alpha is increased, the probability of type 2 error decreases. That's the one. And that's it. So hopefully that was helpful. Again, even if you don't fully understand the underlying math, it's okay. This will help you get through the problem. And these beta problems are not going to show up on the exam, so don't worry too much about them. Just do your best to work through them. And as you work through them more, you understand them better. But for the vast majority of you'll never have to calculate the type 2 error for something. So, and I hope that's you, unless you really, really love statistics. Anyway, have a great day, and don't be afraid to reach out if I can help with anything else.